Have you ever looked at a rainstorm and wondered, what's the tipping point? What does it take to turn something as simple as rain into one of the most destructive forces in nature? Well, today we are going to break down the many ways a flood gets started, from high up in the sky all the way down to the ground beneath our feet. It really all boils down to this one question, right? We see rain all the time. So what flips that switch? What turns a life-giving shower into something that can reshape landscapes and threaten communities? Let's get into it.
So, at its absolute core, flooding is basically a system overload. A great way to think about it is like a sink in your kitchen. If you crank the faucet on full blast and the drain just can't keep up, what happens? It overflows. A river basin works on the exact same principle. When way more water shows up than the ground can soak in or the rivers can carry away, you've got a flood. Simple as that.
Okay, but here's the thing. Not all floods are the same. Not by a long shot. First up, let's talk about the ones that hit with terrifying speed and power. These are the fast floods, and they can show up with almost zero warning. Flash floods are probably the ones you're most familiar with. They're set off by these really intense but short storms that just dump a huge amount of rain in a very small amount of time. We're talking about those big, powerful thunderstorms. The ground just can't absorb it all that quickly. And this is especially true in our cities, right? With all the concrete and asphalt, that water has nowhere to go. So it just runs off straight into the river channels incredibly fast. And, there's actually a way to see this on a chart. It's called a flashy hydrograph, which is a fantastic name. And it's basically a picture of the river having a complete panic attack. You see this super short delay, the lag time, between the downpour and the river level just skyrocketing. That line on the graph shoots almost straight up to a massive peak. It's the perfect visual for just how fast a river can get completely overwhelmed. But, believe it or not, as fast and furious as a flash flood is, there's something else out there that's even more extreme. It's very rare, and it's incredibly powerful. It has a name that honestly sounds like it's straight out of a fantasy epic: the Jokulhaup. Now this has nothing to do with rain. A Jokulhaup is a glacial outburst flood. I want you to picture a gigantic lake of meltwater, trapped and building pressure under a massive glacier. And then, either from volcanic heat from below or just immense pressure, that dam of ice fails. It's a sudden, catastrophic release of all of that water. And we're talking about a mind-boggling volume of water, ice, and rock just being unleashed all at once. So let's do a quick comparison of these fast floods. You've got flash floods, which can happen almost anywhere and are triggered by intense rain. Then you have Jokulhaups, which are locked into glacial regions and are triggered by heat or pressure. Both are unbelievably fast, but their origins, worlds apart. Okay, now let's slow things down a bit and shift from that sudden impact to more of a slow, creeping siege. Right, so not all floods are that sudden, violent shock to the system. Some are much more gradual. They're like a slow siege, building their destructive power not over minutes or hours, but over days, sometimes even weeks. And the way it happens is actually pretty straightforward. It just starts with rain that goes on and on and on. After a while, the ground becomes like a totally soaked sponge. It physically cannot absorb one more drop of water. From that moment on, every single raindrop just flows over the surface, directly into the rivers. And you just watch those river levels rise, slowly, steadily, relentlessly, until they finally spill over their banks. And you see this slow burn flooding happen in different ways all over the globe. In tropical regions, you might have extreme monsoons that bring months of sustained rain. In colder places, it's often a rapid spring thaw when a whole winter's worth of snow melts in just a few weeks. And get this, if the ground underneath that snow is still frozen solid, it acts just like concrete, making all that runoff even worse. Okay, so we've talked about water coming from the sky and flowing over the land. But now we're going to get into a really fascinating twist. Because sometimes the biggest danger isn't the water itself. It's what that water does to the very ground we're standing on. Yep, you heard that right. The water itself is only one part of the equation. The real hidden danger, the thing we don't always think about, is when the land itself starts to fail. And there's a name for this process. It's called liquefaction. Now, you often hear about this happening during earthquakes, but it can also be triggered by severe, prolonged flooding. When soil gets completely waterlogged, it can lose all its strength, all its stability, and literally start to behave like a liquid. And that can cause buildings to tilt, foundations to crack. It creates this whole other layer of disaster on top of the flood itself. So we've got fast floods, slow floods, and even the ground turning into something like liquid. But there's one last huge factor we have to talk about. Think of it as an amplifier.
something that's taking all of these threats and dialing them up.
And that amplifier is our changing climate. It's a true threat multiplier. See, a warmer atmosphere can hold more moisture. That's just physics. And what that means is, when it does decide to rain, it can rain that much harder, fueling more of those intense flash floods. We're also seeing snowpack melting earlier and faster in the spring. And all that increased melting from glaciers is just adding more and more water into our river systems. It really is touching every single process we've discussed today.
And that really brings us to this key idea. The absolute worst floods, they're usually not caused by just one thing. It's almost always a combination. Imagine prolonged rain that gets the ground totally saturated, and then that's followed by a really intense thunderstorm. Or maybe it's rapid snowmelt happening at the exact same time as heavy spring rains. It's when these factors team up that you get the most dangerous and destructive events.
So, what's the big takeaway from all this? Well, it's that every flood has a unique story, a specific cause. Whether it's a catastrophic glacial outburst, a relentless, slow-soaking rain, or a sudden violent downpour. And really understanding that story, understanding the cause, is the absolute first step if we want to prepare for what's coming.
And that leaves us with one last really big question to think about. We know for a fact our weather is changing. The real challenge now is, are we truly ready for how our floods are going to change right along with it?
Thanks for tuning in.